Hey everyone, this is Abhishek Vishwakarma and welcome to my channel Coding Na Kariyo. Today I am going to discuss the lead code problem number is 692 and the question is top k frequent word. It means we need to return top k frequent word. So the description is given an array string words okay and integer k, return the k most frequency integer. It means we need to return k most frequency element. And there is some condition, return the answer sorted by frequency from higher to lower. It means we need to sort answer in be a sorted order based on frequency from higher to lower. Higher come first, then lower come first. If suppose the sort the word with the same frequency by their lexicographical order. It means suppose you have a word A1, you have word A1, now A2, now A3. The frequency of A3 is 5 and the frequency of A2 is 4 and the frequency of A1 is like 6. So the answer is we need to sort based on their frequency. A1 has more frequency than other. Then next come A3, then A2. Now we need to sort our answer based on what? Based on their frequency, higher to lower. And suppose there is a word like love and I, suppose it. This word frequency is 2 and also this frequency word is 2. So if the second condition is if first condition is sort the frequency, sort the answer based on frequency from higher to lower. If any two words loves and I comes same frequency, so we need to sort them in what? We need to sort them lexicographical order. It means like what? Like suppose this. Like suppose we need to sort based on their alphabetic order. Like A B C D E F G H I then L come first come I. It means we need to store first love, then we need to sort lexicographical order means we need to sort the smaller alphabetic order like A B C D E F G H I J K L. It means I come first, then L come first. So we need to store same like that. We need to store the words I come first. We need to compare it. Now both are different, so we compare whose one is smaller in alphabetic order. I is smaller, so first come I, then come love. Okay, and suppose like question, one more word, lead code. Take one more example. Sorry, lead code and love. Then and suppose both frequency is same, like 2 2. So we need to store in lexicographical order. Lexicographical order means compare alphabetic by alphabetic. Like compare first alphabetic word 1 string 1 and then second alphabetic string 2. Like L and both are same, so we need to move next alphabetic. Compare E or O. E and O are different, so we need to find who come first. E come first or O come first? E come first. It means we need to sort. Our short answer is lead code come first, then love come first, then love come. First come lead code, then love. Okay. Now this is a lexicographical order. Okay. And now let's take one example and also discuss how to solve this problem. Let's jump into the whiteboard. Now first we need to do what? First we need to find the frequency of each and every words. Okay. Now I already find it. This in hash map we need to store each word frequency. I come 2 times, love come 2 times, and lead code comes 2 times. 1 times, and coding comes 2 times. The problem is what? If two words have a same frequency, we need to sort what? We need to sort in lexicographical order, and also for this. So how do we sort them? So we do via what? We do via custom sorting. Custom sorting means what? How to customize our sorting algorithm. In the Java, we have a default sorting algorithm, but we want if any data structure, like if data structure store in any order, but we want to store according to our sorting algorithm. So in priority queue, we take a priority queue because they store like maximum number, then lower maximum, then lower maximum, like that. So in priority queue, we have two types. Max heap, it means on the top, the maximum things come first on top, and in minimum, it means and the top of priority queue, the minimum on top of the priority queue. Okay. So first we need to do what? First we need to count frequency. Okay, frequency. We count frequency, then after what? Wait a minute. Then the second is the main problem. An important step is sort. Second step is write custom sorting logic, and third step is store top k element. Like when we store, suppose when we store a1, a2, a3, a4, but the question asks for that we need only top two element. So the answer is top. This is a top two element. So we take the help of priority queue to store top two k element. Okay, if the element is greater than, what, if the element is greater than k, is given, it means we need to return only a top two k element. If the element is greater than k, it means we need to pull out from priority queue. Okay, how do? We discuss in the code, discuss coding part, and the thing is, then find my print top k element, k element, which is our answer. So how do we do? And we also explain how do we write custom sorting algorithm in coding part. Now let's take some things. Let's remove it. And now first step is what? First step is step one is what? Step one is count frequency. Okay. So we need which data structure is hash map. Hash map store frequency of each word. So the key should be a string, and the frequency should be an integer. Okay, and now we take a map frequency, and now new hash map. Okay, now we count the frequency each and every words string. So we write a for each loop. We use for each loop count frequency, put word and frequency. If the frequency is given, it means if frequency is already in map, find this. If this is already given, so if it is given, now add +1, and if it is not given, return 0. And then the step 2 is important step is what? So the second step is write a custom sorting logic. Like, so I want, if data structure is stored in some default way, but we want to store our own logic. So we need to sort, like we need to first sort based on their frequency, then after, if the frequency is same, store in lexicographical order. Okay, like we take to store our top k element. So we take a data structure q and store it in priority queue. Okay, and now priority queue. Okay, now the priority queue, and we want what? We want our own custom logic. Is we take a it's same like in JavaScript arrow functions. We take a two parameters, and then we find it means here we compare two values. Compare with, first we compare if frequency is same. If frequency is not same, sort based on their higher to lower order, and if frequency is same, now sort based on their lexicographical order. Okay, first we need to find the frequency of two words, then we compare it. Find the frequency of A, find the frequency of get B. It means they find the frequency, this F1 and this F2, and we need to assign the value. That this value is a what? It is a frequency number from which is stored, we store in frequency. Okay, and then next, what is if frequency if both frequencies not equal, we return f1 minus f2. It means it compare it. If it compare two words, lower frequency come first. If, like, suppose f1 has frequency 2 and f1 has frequency 3, it means we need to store, we need to what, we take some like a, we take a priority queue. Priority queue means lower frequency, then higher frequency, then like higher. Okay. And then how do I, why we have store like that? Because like we maintain only two k frequent element. This is lower and this is higher, and we pull it and store in answer here, and then we pull it and store it here, like that. Okay, so that's why we take a min heap, where the lower frequency word come on the top, then a higher frequency. Okay. And the next is what? And the next is if frequency is same. So what we need to do? We need to compare to A. If here we reverse the logic lexicographical order, because we store in reverse order. Lower frequency order come first, then higher frequency come, and it compare it. It, like, suppose we take example in previous concept. Now this is lead code. Now we compare it alphabetic by alphabetic. Then E come first. It means lead code come first, then love. Okay. But in heap memory, we need to store in reverse order. It means that lead code come first, and O, then O come, like in alphabetic order. E come first, then O come first. But here we need to store in reverse order. Who come later? Like O come later. So we need to store first, like what? We need to store like first love, then lead code. Okay. When we store top k element, like suppose we store top k element. Suppose we store top k element, and when we pull out this, we need to store this, and then we need to store here. It means we need to sort in front of list, because we need to return what? We need to return list. In the list, first main thing is what? I will take a I will take a min heap, where lower frequency come first, then higher frequency. Okay. And if the frequency is same, the higher alphabetic order word come on top, higher alphabetic order come top, then lower alphabetic order. Okay. And now we write our custom sorting algorithm. Then we need to make sure what? We need to store in top in heap memory, only store top k element. And why we store only top k? It is easy to pop it and store in our answer. So that's why we do like this. Okay. The step 3 is keep only top k element, top k answer. Okay. And for string w frequency dot key set, it means that what? It means that we only traverse in key, in hash map, like hash map store key value, and here key set means only traverse in key, like here only traverse in key. Okay. They only traverse in key. And then now after pq dot offer w, we add the frequency, add the k frequency element into the where in priority queue. Okay. And if pq dot size greater than 0, it means we need to pull that element. pq pull means remove it. Okay. And now we store a top k element. Then after we top k element store in our answer list, result list. Okay. And our priority queue only store top k element. And now we pull one by one. We pull first, we check is not empty. Arithmetic is not arithmetic is not empty. First we need to check, and then after result is return. Oh, sorry, result dot add 0 and pull. We paste. It means we add the answer in list in front side, right? So the main things why we take a mean heap, because mean heap, like suppose mean heap store lower than higher frequency element, but in answer we need to what? We need to store higher than lower, and this thing is mean you store and you add the element in the list in from front side. It means that like first we pull out what? We pull out top of element, and it is remove it, and it will store in front of in front side. Okay, this is list answer, and first whole element is L, suppose L, and it will store in list. Okay, and the now the second the and the second remaining is we pull the remaining is mean higher, where we pull out remaining answer from the priority queue and add in front side. From front side we add, so add it like that in front side, not a back side, like not a we store like H L then H. We store L and we store from front of side, like that. That's why we take a, main heap. You also take a max heap and maintain max heap and store in from backside. But here we take a min heap which store lower and on top then higher, and then after when we pull each and every element, every top element, and store from front side. Okay, store from front side. And the next thing is what? The next thing is return result. Okay, now we run this test case. Yeah, pq dot pull. Oh, sorry, pq dot not pull. That is a function. pq dot pull. Now it come false. I don't know why. Here it will not store the answer. Why? Why? Sorry, here I make a mistake. Uh, if the frequency is greater than k, not greater than 0. If greater than k, pull out the element. It means remove the element. We need to store top k element. Okay. Now again we run these two test case. Now run successfully, and now we submit it. Now we solve this lead code problem. The problem is 692. And thank you guys. Thank you so much to watching this video. And please like and subscribe this channel. And thank you guys.